This episode is brought to you by Eric M., this week's news patron. It's the turn of the century, the early 1800s, and cities are popping up all over the east coast of North America. Cities like Philadelphia, Boston, and New York. Goods are flowing in from all over the world, as well as new settlers, and the countries of Canada and the United States are being forged with horsepower, pickaxes, and shovels. The Industrial Revolution is well underway, and steam power has been in use commercially for about 100 years. But there's something new around the corner, something extremely powerful, something that would change the world. The massive machines that power the Industrial Revolution need one thing: power. First, it was mechanical power to drive the mighty grain and lumber mills that would build the two countries, and soon after that, it would be electrical power that would shape the modern world as we know it today. And sitting smack dab on the east coast of North America, amidst the largest source of fresh water and the fastest growing population in the world, was one of the most powerful natural things on the surface of the planet. This week on Historsea, the harnessing and eventual disasters of the Niagara Falls. Niagara Falls is a spectacular waterfall on the Niagara River, which serves as sort of a natural boundary between the United States and Canada in that area. The falls are made up of three separate waterfalls: the Horseshoe Falls, the American Falls, and the Bridal Veil Falls. The Horseshoe Falls are the largest and most well-known of the three, stretching some 2,600 feet across the Niagara River and dropping about 170 feet to the rocks below. The American Falls are slightly smaller but still very impressive, and the Bridal Veil Falls are the smallest of the three. Niagara Falls has been a popular tourist destination for well over a century, with visitors coming from all over the world to witness the sheer power and beauty of the falls. There are several ways to experience them too, including boat tours that will take you right up to the base of the falls, and you'll get soaking wet. There's viewing platforms that offer stunning panoramic views, and even helicopter tours for those that are looking for a bird's eye view. And in addition to this natural beauty, Niagara Falls is also known for its hydroelectric power, which has been harnessed from the falls since the early 20th century. Today, the Niagara Power Project provides electricity to millions of people in the United States and Canada. Understanding the awesome power of Niagara Falls starts with why it even exists. From as far back as 2 million years ago, glaciers started melting on top of what is now North America. And as the glaciers melted, they left behind lakes, of course. The lakes left behind are what we know today as the Great Lakes, and by itself is a pretty incredible piece of history that shaped the modern world. But the lakes didn't just get left on the flatlands in the Midwest. They had a unique land feature, a giant cliff that runs for hundreds of miles, that runs right through the middle. We talked about the Niagara Escarpment last week in our Erie Canal video. You can see it up here. It's a steep ridge of land that stretches from western New York through Ontario, Michigan, Wisconsin, and Illinois. It was formed over millions of years as layers of sedimentary rock were pushed up and exposed by the movement of the Earth's crust. The Niagara Escarpment is known for its unique geology and scenic beauty, and it's home to a wide variety of plant and animal life. And it also plays an important role in providing clean drinking water to millions of people in the Great Lakes region, and it acts as a natural filter for groundwater. Here's a top-down view of the Great Lakes and their massive footprint in North America. The Great Lakes Basin is a vast area that covers more than 295,000 square miles and includes parts of 8 U.S. states and 2 Canadian provinces. It's a complex system of rivers and streams and wetlands that drain into the Great Lakes, providing the lakes with a continuous supply of fresh water. And that's important, it's continuous, but that water has to go somewhere. Looking at this depth representation of those Great Lakes, we can see that it all starts at Lake Superior. It's by far the deepest of the lakes at 1,300 feet. And as the snow in the area melts and groundwater flows into Superior, it flows slightly downhill into Lake Huron, which is 750 feet deep, and Lake Michigan at 900 feet deep. As Huron and Michigan collect their water from Superior and the mass of land around themselves, water flows into Lake Erie, which is just 210 feet deep. This is a massive amount of water entering Lake Erie, so massive that every 2.6 years, the water in Lake Erie is completely replaced. As this massive flow of water gets into Lake Erie, fed by all of the other Great Lakes, it reaches that big cliff, the Niagara Escarpment that we talked about. And with nowhere else to go, it plunges down the some 250 feet into Lake Ontario. Lake Ontario, through several waterways, eventually finds itself in the Atlantic Ocean, but the drop off that escarpment is what led to Niagara Falls being formed over some 12,000 years of erosion. It's a strange happenstance of glacier melting and erosion, creating one of the most diverse water ecosystems in the world. Even today, harnessing the raging Niagara River is almost impossible, but what you can do is you can cut a canal next to the river, and the size of the canal would control how much water you had to harness. So that's what people did. In the early 1800s, a mill was run by a rudimentary paddle wheel, so even the smallest little canal could deliver enough water flow to give you almost limitless power for your lumber or grain mill. And New York saw the potential in this limitless power. In 1805, New York started granting unlimited water rights or water diversion rights into the little canals to just about anyone who showed up to ask. All you needed was a plan to divert some water and a reason, and they would give you the rights to it. One such sale was to Judge Augustus Porter and his brother Peter. They showed up with a plan, and they bought some water rights, specifically to the rapids on the American side of the falls. But there were some problems, you see. They saw the future, and had they bought those water rights 50 years later, they would be insanely rich. But they were too forward-thinking. The problem was that the technology at the time was little more than the age-old paddle wheel, and you could use that to its full potential with a much smaller waterfall, a much less flow of water. Trying to tame the mighty Niagara Falls just didn't make any business sense. The Porters offered their land rights to any business that was willing to come and dig a canal to make use of that water, but nobody was buying. It wasn't until 1860 that things started to change a little bit when the Niagara Falls Hydraulic Power and Manufacturing Company decided to step in. They built a canal finally along the side of the Niagara that was 35 feet wide and 8 feet deep, and it ran the raging water off the Niagara River in a controlled way where local businesses could come to harness the power. But again, too soon for the technology, and they promptly went out of business, sort of leaving that canal to rot. With technology being so far behind the awesome power of the Niagara Falls, no one turned it into a successful business until something else in the world changed. Something big. Something called electricity. One of the earliest discoveries related to electricity was made actually by the ancient Greeks, if you can believe it. They observed that rubbing certain materials together, such as amber in their case, would create an electrical charge. The term electricity actually comes from the Greek word electron, which for them meant amber. In the 18th century, scientists such as Benjamin Franklin, you may know him, and Alessandro Volta began to conduct experiments on electricity, discovering new properties and ways to harness its power, and that was important. Franklin famously conducted his kite experiment, where he flew a kite with a metal key attached to it during a thunderstorm to demonstrate the presence of electrical charge in lightning. The invention of the battery in the early 19th century by Volta paved the way for the development of electrical circuits and the creation of the first electric motors. You could actually turn electricity into a force of motion. But it wasn't until the late 1800s that it became applicable to the world on a large scale. Enter Thomas Edison. In the 1800s, Edison was working at his company in New Jersey on all things electrical, and he was using DC power, or direct current. He had generators that were producing DC current, and he was inventing things that he could do with that DC current, most notably his invention of the electric light bulb. North America at the time was still lit by candlelight after the sun went down, but Edison was a visionary and he saw a future where every home would have an electric light and perhaps down the road more uses for electricity. So he set out to accomplish that goal of getting DC power into every home. The problem with DC, because of the way direct current works, is that it could only go so far down a set of wires, a few hundred feet in the early days. Edison envisioned solving this problem by putting a DC power generating plant in every large building in sort of every city block to give power to anyone who was willing to pay for it. Had Edison's vision come true, things might be a lot different for us today. Much like you buy a water heater for your home to heat the water, you might also have to buy some sort of DC power generating plant or subscribe to the one in your neighborhood. Much like VHS versus Beta, or more recently HD DVD versus Blu-ray, there was a competing technology that would do things a bit differently. Nikola Tesla had just come over from Croatia and he got himself an entry-level job at Edison's company in New Jersey. The problem of the day for Edison was that he had hundreds of these DC power generators all over the place, and they were very fragile. They would break down constantly. And as the story goes, Thomas Edison offered a $50,000 reward, a lot of money in the day, if someone could fix the DC generator problem. So Tesla, the aspiring engineer, set out to do that, and he fixed all the DC generators. But as it's told, Edison actually refused to pay him the $50,000 in reward. But Tesla wasn't finished. Tesla had been long experimenting with AC power, or alternating current, and while DC power is sent out over a power line in one direction at a constant voltage, it fades out as it travels and at some point becomes something you can't even use, whereas AC power alternates directions back and forth and its voltage can be much higher, meaning it can travel hundreds of miles instead of hundreds of feet. With AC, you could build one big power plant and power an entire city. So Tesla quit his job working for Edison and went out on his own to perfect his idea. After years of struggle and hard work, his AC power solution caught the eye of a notable investor, George Westinghouse. In 1869, at the age of just 22, Westinghouse founded his first company, the Westinghouse Air Brake Company, which revolutionized the railroad industry by introducing a safer and more efficient braking system for the trains. The air brake system used compressed air to stop the trains, replacing the older, less reliable system of manually operated brakes. The invention not only made train travel safer, but also enabled trains to travel faster and carry heavier loads. We still use a version of that air brake system today, both on trains and transport trucks and large vehicles. Basically, with the train cars and air brakes on large vehicles, the brakes are always on. You can't move the car or the trailer or whatever it is. But if you hook up an engine with a built-in air compressor, you can push air down the line, which opens up the brakes. This means that if anything goes wrong and you lose air pressure, all the brakes turn on and everything comes to a stop. It's kind of brilliant. After making his fortune, Westinghouse turned his attention to the electrical industry, and he didn't like the DC system either. He saw the bigger picture and what AC could do, so he partnered up with Tesla to take over the world of electricity, and so began what was dubbed the War of the Currents. Hi, I'm Tim from Historsea. This is a brand new channel, and these videos are brought to you by patrons, people who give a couple of bucks an episode to make this all possible. I couldn't do it without you. If you value these videos and you want to help out, please consider becoming a patron. Patrons get early access to videos, and they're involved with the discussion on what videos we'll be making in the future. I look forward to a great community that we're going to build together. The War of the Currents was on, and in a world where everyone was lighting their homes with candles and gas lamps, the thought of an electric light bulb seemed astonishing. Being able to light a room with the flick of a switch was mind-boggling, and for most, they'd never even dreamed of it, let alone seen it with their own eyes. And then the 1893 World's Fair would be that mind-blowing experience that the electrical industry needed. The World's Fair was a large international exposition held in Chicago every year to celebrate the anniversary of Christopher Columbus's arrival in the New World. The fair was held from May 1st to October 30th, and in 1893 attracted 27 million visitors from around the world. The fair was organized to showcase the latest and greatest technological and cultural achievements of the time, with exhibits from 46 countries and 38 states in the U.S. The fairgrounds covered more than 600 acres of land and included more than 200 new buildings and exhibits, including the world-famous Ferris wheel, which was designed by George Ferris, standing 264 feet tall. The fair also featured exhibits on art, science, and culture, including a series of lectures by luminaries like John Philip Sousa, Mark Twain, and Helen Keller. One of the most popular exhibits was the White City, a series of ornate white buildings that housed exhibits on industry and technology. The fair was also notable for its impact on American culture, as it introduced many new inventions and trends to the public, like the invention of the zipper, the hamburger, and the introduction of Pabst Blue Ribbon beer. And for 1893, the World's Fair would be illuminated with electric light bulbs powered by electricity. Tesla's AC electricity specifically, it said that some 100,000 light bulbs in all shone over the World's Fair and proved to everyone that AC was the way of the future. Now, the mighty Thomas Edison was angry, very angry. His counterattack was brutal. He went on a smear campaign warning the world of how dangerous AC power was. The much higher voltage that AC uses is in fact more dangerous, he's right. The campaign electrocuted dogs and horses and even an elephant right on the streets of New York with Tesla's AC power to prove his point. They distributed flyers warning people. Edison even promoted the use of an electric chair for executions powered by AC power to scare people off of this new technology. But in the end, his campaign couldn't derail AC power as the better option, and AC ended up winning. And now, armed with that winning technology, Westinghouse and Tesla set out to find a way to create an abundance of AC power, enough to satisfy the need of every home and business who could possibly want it. And Tesla knew just how to do it. He turned his eye to Niagara Falls. The Niagara Falls Power Company awarded Tesla and Westinghouse the contract to build the first 2 power generators at Niagara, and they started construction, but this wouldn't be built in the ways of the past. There would be no paddle wheels here. First, they had to build a tunnel, and tunnel the raging waters off the Niagara in such a way that they could control it. The tunnel would take 3 years to build, employing over 1,000 workers. It would be 6,700 feet long in all, and during its construction, some 28 men would die in accidents. From there, water would be drawn off the tunnel into what are called penstocks. Now, these are massive vertical pipes. The first ones were 8 feet across, running water from the raging Niagara River straight down some 180 feet. And that huge volume of water and energy contained in it reached the bottom, it would spin a turbine. The turbine would then spin a shaft that ran all the way back to the surface, where they would place a generator. The insane amount of energy this produced to spin those generators was unheard of. Some 100,000 horsepower right out of the gate that they could use to make electricity. We still use the fundamentals of Tesla's technology at Niagara Falls today. If you think about the generators they use to make electricity, basically you spin a shaft on one end and electricity comes out the other end. If you, say, slapped a paddle wheel on the shaft end and stuck that paddle wheel in the raging Niagara River, you would get a lot of AC electricity from it. But if you instead funneled that raging river into 8-foot wide pipes, and then ran those pipes 180 feet straight down into some turbine blades, the amount of energy that the water put on the turbine blades is almost unimaginable. Now, you build a power plant and you stack 6, 8, or even 10 of those big pipes and turbines into one power station, and the electricity produced is massive. But the hungry cities sprouting up always demanded more. Over the years, many of these power stations on Niagara Falls were built, the Canadian side and the American side, providing power to millions and millions of homes and businesses, but the power companies weren't allowed to just run hog wild. The business of electricity is a big one, and there's a lot of money at stake. So naturally, the power companies wanted to keep making more and more. And thanks to the physics of AC power, they could send that electricity for hundreds of miles to customers further and further away. But the natural beauty of the falls couldn't be destroyed in the process, so much so that several treaties were signed between Canada and the US limiting the amount of water either side could divert away from the falls. The falls were, after all, a major tourist destination. If not just for the natural beauty, they had to be preserved for the economy of Niagara Falls. Tourism in Niagara Falls began in the early 19th century when the area was first recognized as a natural wonder of the world. The first hotels were built in the 1820s, and by the mid-19th century, Niagara Falls had become a popular honeymoon destination. In addition to the falls themselves, the surrounding area of Niagara Falls offers many other attractions and activities, including casinos and amusement parks and famous wineries. There are also numerous restaurants and shops in the area, as well as cultural and historical attractions, such as the Niagara Falls History Museum and Niagara Falls Culinary Institute. The tourism industry in Niagara Falls is a major contributor to the economy of the region, providing employment for thousands of people and generating billions of dollars in revenue. With all the power stations aging, it was only a matter of time before what could go wrong would go wrong. But before we get to that, please take a moment to hit the subscribe button. And if you like this video, give it a thumbs up. Both are free for you and they would really mean the world to me. Historsea is such a young channel and I'd love to keep making these videos, and seeing you subscribe and like and leave a comment really does inspire me for future episodes. In 1956, the Shulkoff power plant on the American side collapsed. On May 1st, 1877, Jacob Shulkoff purchased an existing canal and its land and water and power rights for $71,000. When Shulkoff had taken control of that canal, power at the time was being transmitted by a combination of belts and drive shafts. Electricity was still in its infancy at that point and only really used for telegraphy and the newly invented telephone. But in 1895, Shulkoff built his second power plant directly in front of the old power plant. And this would be the new technology of the massive penstocks with turbines. The sides of the gorge were walled in, and behind the walls, the shafts carried water down 210 feet to the turbines located just above the water level. Behind these shafts and rear walls of the new plant were the old cuts in the rock face, which originally were used in the era of the belt and shaft drive technology of the original power plant. And over the years, water seeping behind the wall had undermined the rock face and the gorge behind the plant. The morning after the disaster, a local newspaper headline read, "Slide crashes power plant. Second building is toppling onto ledge. 39 escape, 1 believed dead. Officials say losses $100 million. Building flies apart like a jet stream." The article thereafter read, "A rock slide roared like 1,000 lions, followed by 3 earth-shaking electrical explosions, buried 2/3 of the Shulkoff power station in Niagara Falls at the base of the Niagara Gorge shortly after 5 p.m. 39 terrified workers emerged from the plant just as the remaining section of the plant burst into orange flames. Richard A. Draper, age 39, of Lewiston, New York, a maintenance foreman, was hurled through the window into the river. He's presumed dead. A jet-like burst of water from a broken penstock carried his body along with thousands of tons of debris into the surging maelstrom. 3 men were treated in hospital. 2 men were blown out of the building with Draper, were picked up by a motor vessel from the Maid of the Mist Company. Another worker was hauled up the 215-foot face of the gorge on ropes. According to Niagara Mohawk Power Corporation Vice President Charles J. Wick of New York, the damage is estimated at $100 million. The building and its equipment cost $36 million to build back in 1918. A survivor of that disaster, a man who was in the building, said this in an interview, I started work that day as a janitor. There was water seeping in, and we were trying to keep it away from the generators. The pressure on the building was tremendous. The windows facing the river just popped out. I had to go and operate the second elevator for emergency evacuation, but that elevator got flooded out. I returned to the floor of the section that was wiped out. I started down to my locker, and the concrete floor would buckle up, and I would jump over it. The area where my locker was devastated. I returned to the generator floor and was going to get my shirt that I had wore for work. I opened the door to the toilet area, and my shirt was in the area just off the area next to the sinks. And I saw the sinks crack in half and the toilets into shambles. I closed the door and came back. Then the wall toward the falls came crashing down. I then headed to the elevator. Water and stone was following into the forebay. I stood under the steel doorframe watching and did not hear the elevator door open. The operator called to me and I jumped on. It took 45 seconds to reach the top, and I saw the gorge collapse on the area that I was in. The rest of the crew ran through the section that was not crushed yet and into the gorge. Then I helped maintenance close the gates to stop some of the water flow. The Shulkoff disaster was the only one of that magnitude to impact the power plants of Niagara Falls, and it led to a lot of new safety innovations and inspection procedures, but it wasn't the only thing to ever go wrong. Not the fault of the Niagara Falls power station, but a nearby piece of equipment that helped distribute the power that the falls were producing. The Northeast blackout of 1965 was a significant disruption in the power of electricity, affecting parts of Ontario and Canada, and Connecticut, Delaware, Maryland, Massachusetts, New Hampshire, New Jersey, New York, Pennsylvania, Rhode Island, and Vermont. Over 30 million people and 80,000 square miles were left without electricity when everything went wrong. The cause of the failure was the setting of a protective relay on one of the transmission lines from the Sir Adam Beck Hydroelectric Power Station No. 2 in Queenstown, Ontario, near Niagara Falls. The safety relay was set to trip if other prospective equipment deeper within the hydro system failed. On a particular cold November evening, power demands for heating and lighting and cooking were pushing the electrical system to near its peak. Transmission lines heading into southern Ontario were heavily loaded. The safety relay had been misprogrammed, and it did what it had been asked to do, to disconnect if the loads were higher than they were supposed to be. As a result, at 5:16 p.m. Eastern Time, a small variation of power originating from the Robert Moses generating plant in Lewiston, New York, caused that relay to trip, disabling a main power line heading into southern Ontario. Instantly, the power that was flowing on the tripped line transferred to other lines as a failsafe, causing them to become overloaded. Their own protective relays, which are also designed to protect the lines from overload, tripped, isolating the Beck station from all of southern Ontario. With nowhere to go, the excess power from the Beck station then flowed east, over the interconnected lines into New York State, overloading them as well, and isolating the power generated in the Niagara region from the rest of the interconnected grid. The Beck generators with no outlet for their power were automatically shut down to prevent damage. The Robert Moses Niagara Power Plant continued to generate power, which supplied Niagara Mohawk Power Corporation customers in the metropolitan areas like Buffalo and Niagara Falls. These areas ended up being isolated from the rest of the Northeast power grid and remained powered up. The Niagara Mohawk Western, Huntley, Buffalo, and Dunkirk steam power plants were knocked offline too. Within 5 minutes, the power distribution system in the Northeast was in chaos, and the effects of overloads and the subsequent loss of generating capacity cascaded through the entire network, breaking different grids into sort of islands, and station after station experienced load imbalances and automatically shut down. That power outage left some 800,000 people stranded, unable to get home, or stuck in the subway or in elevators, but it hasn't happened since. And Niagara Falls now produces some 4,400 megawatts of power, which makes it one of the largest hydroelectric power stations in the whole world. However, the actual amount of power that Niagara Falls produces kind of varies, depending on a few factors, including the time of year, the water flow rate, and the number of turbines that are currently operating. On average, Niagara Falls generates enough electricity to power about 3.8 million homes in the US and Canada. Most of us who live in the region of Niagara Falls go visit it quite often, the same as you would visit the Grand Canyon if you lived in America's Southwest, or the Eiffel Tower if you lived in France. It's a massive tourist destination, and many people have weddings and honeymoons there. The Strip on the Canadian side has been likened to a tiny Las Vegas with its hotels and attractions and its casinos, and everyone who grew up within a few hundred miles of the falls has that one quintessential picture from their childhood of them leaning on the wall with the Great Falls in the background. If you like this video, please don't forget to subscribe and hit the like button, and please leave a comment below letting me know what you would like to see in future episodes. This has been another Historsea video. I will see you next week.